me, we are going for a short presentation. So with the agenda, a short video about the site, and finally the safety rules here. So first of all, just to present the point of view on Schneider, which called impact. I can read this small sentence. This is a kind of hackathon. You are going to have a break in the afternoon, and right after you are going to make short, very short, the Thesis Deca, Thesis K, Thesis Ultra, and Thesis Island that we are going to see in production. And we are also producing contacts, tips and contacts. We are going to see this in the chemical engineering after in production. We continue. So I hope you enjoyed your visits of the plant. And now we are going to switch to the workshop part. So I'm going to explain quickly what's going to happen. Now I'm going to explain the main subject of this workshop. Then we are going in production, peer groups to manipulate some sensors. And after the lunch, we are going to analyze the data we got with these sensors. The coiler, the production of coiler. This is this tiny black box which allows us to have some data, some temperature sensors, etc. So now we are going to explain a bit the architecture. Some sensors are connected to the IT box where there is a panel server and a PC. The panel server is going to transmit the information of the sensors to the PC, and then we can do everything that we want, like dashboard. We can analyze the data with Aveva. We can put the data on the database, etc. And now what we are going to do is to, first of all, install the sensor. So we are going to do this on conveyors. So there is conveyors per factory. And the idea...
Buradan sonra
We will repair
çekmemiz
some
lazım.
place.
Just, can you place it more?
Okay.
Because it is too close to the other. Of the workshop that you will be working in afternoon. The first part you saw was installing the sensors and the data that is coming from the sensors that you would use in this machine learning model. So have you heard about AI, machine learning, or anything that comes into your mind when you hear these words?
Yes.
Go on.
Yeah, I heard it. Yeah.
What are the words like you feel?
We are having a data and we are training the machine with that data. So I know this.
Okay, and have you worked with any machine learning models before?
I did with RoboFlow for image processing. Sorry.
Okay, so this would be your second part of the workshop where you will be given the data. Already seen a hackathon. What do you know about a hackathon?
There is a time limit and we are doing something in the time limit.
Yeah, exactly. So this is also the same concept of hackathon, except since you are learning the machine learning, you are in the learning phase as a skill machine learning, you would be given the code, you would be given everything, the code, the data set, the results, all are there. You just have to run it. You have to brainstorm about the data, the variable, and why it is a variable. For example, in the brainstorm phase, some of you manipulated the captors, the sensors. So you will know The sensor sends 4 variables, 4 data points. That is the humidity, the temperature, the battery, and the distance. If you're working in an industry, you need to know, or if you want to know or be an analyst or a data scientist that uses this for predictive analytics, it's important that you know how you manipulate it. So this hackathon will give you an entire idea, basics, everything that will help you to grow in your career. And the ability to reason and do logic comes machine learning. This is the part that helps AI to learn the pattern. We already give a data to it. We already have the programming capacities for the machine learning. This is the only part of AI that needs a human intervention. So here you define it. You define what you want from your AI. Without machine learning or the abbreviation ML, it's not possible for an AI to understand what it's doing. The major task of today's workshop. What do you know about predictive analytics? Or have you heard this prediction, maintenance, or analytics in other domains or settings?
Something to happen, like you guess.
Yes, that's a simple definition. We have to guess what's going to happen in the future. This is the very simple definition and already did. Right now, what you did was recording the data. You went and you installed the sensors in the place where we want the data to come from. This was the first part that you did to gather the data. It's important to know that where the data comes from. And various sources, because if you know you manipulated 2 sensors, one is Zana, the other one is CL110. So various sources. We don't have one source, we have multiple sensors for multiple products. This is the first part. You did it. The data is going to now stored in the database.
And let's start the presentation. Firstly, the first question is, why did you choose linear logistic regression for the task? Did you notice any difference? We chose linear regression because logistic regression gives you a prediction which contains 1 and 0, and you have seen all the Excel. We have so much number about the sensors. So if we use linear, probably prediction will be better for us. We thought that, and linear gives us numerical data, so that's why we selected it like that. Thank you.
Now I'm going to talk about what challenges did you face during this hackathon. Firstly, the computer language was French, and we were not used to the keyboard, of course. And the technical part, the analyzing charts confused us. We spent much more time during the work, and of course this was our first experience in data analyzing. So that's the challenge we during this hackathon.
Yes.
How would you improve the field of predictive analytics? We can add more sensors for more possibilities and keeping data flow stable. That's important.
So, what did we learn from this hackathon? Teamwork, we worked all together, for people we worked together and did the hackathon. Simple data analysis and understanding that machine learning is important and comprehensive. Oh, there's a technical issue, sorry about that. Thank you for listening.
Can you get back for
Yeah.
the third question? Third one.
There you go.
And also we
Yes.
can add, yes. And also we can add, you have seen the chart, you have seen the Excel. We can see anomalies when we after create the charts, but we cannot see what is the wrong. It can be from humidity, temperature, but if we add a new, how can I explain it? Bir kısım daha ekleyip hangisinden kaynaklandığını söyleyebilirsek anomalinin daha güzel olur. But you need to help me for explain it.
So, she says that we cannot see that one thing that
That will
is the anomaly. But
for understand anomaly. For example, anomaly because of humidity, because of temperature, because of blah blah blah.
yeah.
Like that.
Like the battery burned because of the heat.
Yes, thank you so
We
much.
cannot see that in the anomaly.
Because all these are Turkish, I can explain. Thank you so much.
Thank you.
We firstly put in a graph what went wrong, so how many things went wrong or had some kind of thing that wasn't perfect. That were 4,000 things and 2,000 things went like well. So we checked what went wrong. The battery looks exactly the same. It's in yeah, it's relative to the other thing what went wrong, like 4,000 to 2,000. This you see, this is higher than this, but the line is exactly the same.
Yeah, when you see the humidity, when it goes wrong by the zero, the darker blue one, it's way lower than when it, wait, no, this is good. When it's wrong, it's way higher than here. So when the humidity is way higher than normally, so around like 28.5 and higher, there's more anomalies than when it's low.
With temperature, it's the same. When the temperature is lower, there's a bigger chance that it goes wrong than when the temperature is higher. This should be like the normal temperature. So when the temperature is lower than this, something could go wrong.
The distance. So you can see when there's an anomaly, there's way more distance between the products than when it goes right. So there's a distance of 95 and a bit higher when it goes wrong, but it's just okay when it's like 75, 85. But when there's like less products on the conveyor belt, it's more likely to be an anomaly.
The anomalies mostly happen in the morning from like 12 o'clock at night to 9 o'clock in the morning. So it could be the people that work between those times, or that at night the production is lower. So you see that there is a difference in when in the day it happens.
The conclusion. The voltage from the battery doesn't define the amount of anomalies. The most anomalies happen when humidity is high. When the temperature is lower than 31 degrees Celsius, there are more anomalies. If there is an anomaly, there is probably a distance 95 from the other product. And the last one, the most anomalies happen at night, between midnight and 8 o'clock.
These are our answers to the questions. We used the logistic regression because you categorize the data in groups instead of just making a line. This made it for us clearer to see which thing happened when. The most difficult thing for us was using the AZERTY keyboard because at home we have a QWERTY, so it's all a bit mixed up. We got all the graphs you saw by using AI. So to make the process even easier, we could invest in a better AI that is smarter and works more efficient. What we learned today is how to analyze data, basically, effectively.
That was it.
That was our presentation.
This is the presentation of Spain and Portugal. Hey, my friend.
Why did you choose linear or logistic regression for this test?
So first of all, we choose logistic regression for this test because the logistic has a better accuracy, and the linear has some anomalies actually.
What challenges did you face during this hackathon?
So the challenges that we faced are the language barrier, and we never worked with this program before, so it's kind of hard. And actually, we are not used to these keyboards. So, how would you improve the field of predictive analysis?
We work so little that we don't know how to improve the program. We should need more time to find out.
So, what did you learn from this hackathon?
In this work, we learned how to analyze in groups and compare logistical system with the linear system, and also to detect analogies. Analogies. And
Thank you for listening.
Okay, so first of all, I would like to introduce my team. We have 4 chemists and 2 programmers. So that aside, we didn't really get a concrete result, but we did go more theoretically, and we kind of, on the theories, decided that maybe the logistic regression was a bit better since it would work for the mass production, since it more clearly tells you where are the anomalies and at what time. So the challenges we faced were pretty straightforward. We have limited knowledge on programming, the time was kind of a big thing. We had one computer, which we didn't kind of first, we had to orient on the keyboard. And yeah, maybe some improvements would be making more, adding more sensors in the factory and production, using more AI, and what did we learn? Some more teamwork and how to work under pressure.
Learning models for predictive analytics. Regression models, linear, are used to predict the remaining useful life of equipment. Examples, predicting that a motor ride will fail in 15 days.
Classification model, logistic regression, are used to predict whether a failure will occur in yes, no. If a pump will fail within the next 24 hours.
The challenge we passed where the data analysis was pretty hard for us. We are not really good in English.
We would improve the field of predictive analytics by adding more sensors. We learned everything because we didn't do these kind of exercises in our lives.
Okay.
Thank you. All those presentations were great, and I'm happy to see that everybody tried. Everybody gave their best, and so that's very nice. And now Rodney is going to make a conclusion of the activity, and I will end with a conclusion of the journey, like a summary. So,
okay. So to begin with summarizing the hackathon, it was great to see all of you taking the effort, the initiative and the teamwork. I really appreciated the way that you found either it's linear or logistic for this team, finding the more data pre-processing parts of the time and the temperature, which was very commendable. It was also very good to see that the other teams were honest about needing more time for data analysis, because whenever we do a data science project or any machine learning project, we do need a lot of time to find the data points, to find the use cases. And definitely one of the fields we can improve in predictive analytics is installing more sensors. It can give us more variability, more data points. It was a great point from the industrial point of view. Moving to the technicality, I would like to clarify for a prediction model that is binary 0 and 1, we have to always use logistic regression, because it will give us a specific prediction result which is binary. So if our main goal is to predict and the target variable is already 0 and 1, we just use logistic straightforward. We can also use linear regression in prediction, but it's more on the correlation side. So we can use it to have a numerical significance where we can find out why this variable is reacting to the target variable. So for here, logistic was better, and if you saw the evaluation metric, it gave you 1. 1 means 100% accuracy. So the logistic is predicting the entire anomaly with 100% accuracy, which means we have a higher chance of prediction with accuracy and precision with logistic. However, the linear gave you around 97%, which tells us that maybe somewhere the linear regression is incapable of finding the predictions. So this would be the summary of the hackathon, and I believe you got an idea of how we can do basic data analysis, how there is integration with these notebooks, and how you can actually create a basic model to predict anomalies in your domain, in IoT, or anything in predictive maintenance. Now you have the use case, you have the basis to create anything.
So to end the journey, I would have to say some words. Thank you. I hope that you enjoyed your visit, your workshops, like the installation. The two groups did very different things. One was with Christophe, measuring temperatures and humidity, and another was with me to install a counting sensor. So they weren't the same thing, and you tried your best. It was very nice, and even during the activity, even if we know that the activity was kind of difficult, it was different between the groups, etc. Everybody tried their best, had a conclusion and a wonderful presentation. So thank you everybody, and I hope you enjoyed your visits.
Dans etmek istersen kırık kalpler sonunda bana hiçbir zaman dönme arkadaşça yana dostça beni gerçekten sevdiysen söyle asla hayır. Hocam Mert'ten derin aynı olana kalıyor. Herkese basit. Kisas, kisas, kisas. Ama iki tane oldu öyle bana öyle mi? Tek kapıdan tutto contestando. Kisas, kisas, kisas.